So let's go over that question that you did on your own. Write an equation in slope-intercept form of a line that passes through the point -2, 11, and is parallel to this line right here. So again, we're using y equals mx plus b. I need to find the slope, and I need to find the y-intercept. So what's my slope? I don't know directly what it is, but it is parallel to this line. And the slope of this line is -1, which means the slope of my line is -1. What about the y-intercept? Well, again, that y-intercept is not useful. That is the y-intercept of this line. I'm not finding this line. I'm finding the line that's parallel to it that goes through this point. But this point isn't a y-intercept. It is simply an x and a y value. So I'm going to use these values and plug it into my y equals mx plus b equation. Right? The y is 11. The m is -1. The x is -2. I'm going to solve for b. And I'm going to get b equals 9. Therefore, my equation is y equals -x plus 9. Again, if you're not getting this question right on your lesson, please raise your hand and talk to me so we can make sure we work those things out. That way, when you get to your homework assignment, you can run through those ones. Okay. All right, next example here. Determine whether lines are parallel or perpendicular. So we are given 3 lines here, and we want to determine which lines, if any of them, are parallel or perpendicular. So we need to look at slopes. Slopes are the thing that determines if they're parallel or perpendicular. Remember, parallel means same slope, and perpendicular is the negative reciprocal. So if we look at each line and compare their slopes, we can tell you which of these 3 lines are parallel and which of these lines are perpendicular. They're negative reciprocals. So let's check the slopes of these lines. So first line, line 1, y equals 5x minus 3. What's my slope? Well, that's in slope-intercept form, so I know it's 5. Great. I'm going to use a different color. Red is played out, right? Everybody uses red. Let's use blue. Because, nobody uses the color blue. It's totally underground. Okay. Line 2, x plus 5y equals 2. I don't see a slope in there right away. I want to convert this to slope-intercept form. I'm going to do a little bit of work down here so I can figure that out. Because I don't have a slope in standard form, so I'm going to convert it to slope-intercept so I can do that. So the first thing I'm going to do is subtract x from both sides. And then I'm going to divide everything by 5. So I end up with y equals -1 over 5, right? -1 over 5, x plus 2/5. So the slope of line 2 is -1/5. And what about line 3? Okay, we need to find the slope. Again, this is in standard form, so let's convert it to slope-intercept. I'm going to add 2x to both sides. That's -10y equals 2x. I'm going to divide by -10. I'm going to get y equals 2 over 10, which I can reduce to 1/5 x. So here I have a slope of -1/5. Also, just interesting to note, to remind you, remember there's a y-intercept of 0 right here. So this is an example of direct variation. Just don't want you guys to forget that vocabulary. Direct variation is when we have a y-intercept of 0. So don't forget that. Okay, we have all the information we need. We have the slopes of the 3 lines. So let's compare them. What's parallel, what's perpendicular, what's neither. So same slopes are parallel. So it looks like line 2 and line 3 are parallel to each other. Negative reciprocals are perpendicular. So that means that if I flip it and make it negative, that's what it would be. 5, when I flip it, is 1/5, and make it negative is negative 1/5. So it looks like line 1 and line 2 and line 1 and line 3 are perpendicular. So line 1 is perpendicular to line 2, line 1 is perpendicular to line 3, and line 2 is parallel to line 3. All right, you've got another question like this one on your canvas. You're going to have 3 lines that you're going to have to find the slopes of and see if they're parallel or perpendicular. Please go and do that problem now.